This is about how to do a confidence interval when we don't know sigma, when all we know is S, which is the standard deviation of a sample. Okay? If we don't know sigma, we have to use a different distribution. We cannot use the Z distribution. We have to use the T distribution. Okay? And I will write, for those of you who attended class, I really stress that you should write this down. Okay, this is the rule for when to use Z or T. So, whoop, why is this not working? Okay, so when, I have no idea why it's doing that, when to use Z or T. Please stop making those boxes around everything I draw. Okay, so the rule is if sigma is unknown and our sample size is less than 30, we use the T distribution. Okay, but if sigma is known or our sample size is greater than or equal to 30, we use the Z distribution. Okay, so as I mentioned in class, you just have to memorize that. And I apologize for these weird boxes around what I've written. I have no idea why it's doing that. So let's go back and look at this problem. Okay, it tells us that this owner of an egg farm wants to estimate the mean number of eggs laid per chicken. A sample of 20 eggs showed they laid an average, I'm going to make this a little bit bigger, an average of 20 eggs per month with a standard deviation of 2 eggs per month. Okay, so as we always do, let's pull out the important information. Okay, so here's our N, our sample size is 20. Okay, and that sample laid an average of 20 eggs per month. So that is our X bar. That's our sample mean with a standard deviation of 2. Okay, now the English in this might confuse some of you, but that's an S, that's not a sigma. Okay, that's the standard deviation of the sample. Okay, so we don't need to do B. Okay, that's theory. We don't need to do theory in this class. The first question, what's the value of the population mean? Well, as we've been trying to get at through the whole course, when we don't know a population parameter, the best estimate is a sample statistic. So we don't know the population mean here. It's unknown. Okay. So our best estimate is our X bar. Okay, and our X bar is 20. Okay, so to kind of drill down on the accuracy of that estimate, we can construct what is called a confidence interval. Okay, now they want us to do a 95% confidence interval. However, we don't know sigma. We only know S. All right, and our sample size is less than 30. So it fits those rules that I showed earlier for using the T distribution. Okay, so we're going to use the T distribution. Now, when you have to use the T distribution, you have to find what's called degrees of freedom. Okay, before you can find your critical T value. And degrees of freedom, which is called dF on our table, is just n minus 1. So since our n is 20, our degrees of freedom is 19. Okay, now we'll go and we'll find our critical value of T. Okay, we want a 95% interval and our degrees of freedom is 19. So we'll go to our T table. Okay, 95% confidence level, that's here. And our degrees of freedom, I'll narrow this a little bit. So 95%, and our degrees of freedom is 19. 95% and 19. Okay, So we're just going to find where those two things intersect. So 95% confidence, and our degrees of freedom is 19. So our critical t-value is 2.093. So let's go back to our slide. Okay, so our critical t-value is 2.093. Okay, and now we're going to make a confidence interval. So the confidence interval, when we don't know sigma, the formula is just slightly different. It's x bar plus and minus critical value of t times s over the square root of the sample size. Okay, so our x bar is 20, and we're going to take that plus and minus our critical t-value, 2.093, times our s is 2. Oh my god, I don't know why this stylus does this sometimes. Our s is 2. Okay, and our sample size was 20. So over the square root of 20. Alright, so that is going to work out to 20 plus and minus 0.936. Okay, and as I told you in the previous video, you need to know that this figure, whatever we're plussing and minusing, we can call it the half width. It can also be called the margin of error, but for the exam purpose, half width is the term that they're going to use. Okay, so I kind of ran out of space here, so I'll write, you know, here's our confidence interval, the really proper final answer. We've got to calculate the lower confidence limit and the upper confidence limit. And the lower confidence limit is just our point estimate minus the half width. Okay, and our upper confidence limit will be the point estimate plus the half width. Alright, so the lower confidence limit will work out to be 19.064, and the upper confidence limit will work out to be 20.936. Alright, so then the final question, would it be reasonable to conclude the population mean is 21 eggs? Well, all you have to do in a question like this, we have our lower confidence limit, we have our upper confidence limit, and a reasonable estimate needs to fall between those two values. Okay, so 21 is higher than our upper confidence limit, so no, it's not reasonable. And 25 is even higher than our upper confidence limit, so that is not reasonable either. Okay, so the primary things, you know, you really need to take from this video, I'm going to discard these because I don't need them anymore, is, yes, this weird boxing. Okay, you need to know this rule of when to use Z or T. Okay, if we don't know sigma and our sample size is small, less than 30, we've got to use the T distribution. And when we use the T distribution, you've got to calculate degrees of freedom. Okay, and degrees of freedom is always the sample size minus 1. Okay, now when we know sigma or the sample size is big, it's greater than or equal to 30, we can use the Z distribution. Okay, so you've got to memorize those. That will not be on your formula sheet, and you also need to know how to use this T table.